Just got this part off of the printer, and it is a variation or modification of my pivot truck, as I call it. This is what earlier design. This one still has the supports on it, and I want to see how well the supports worked, how well did it print, and are there any issues that I need to worry about as I go along. You can see these are the lines of the Simplicity 3D splicer puts in for support. So I'm going to begin to remove these and see what we have. That side support, the part was printed like this. So this was the edge laying down, and there's some stringers, but that's not a big deal. You see there's some support here in the middle between these two pieces. This is very important. And there's one out here on the end. Oh, that came off nicely. There's a little bit left. I can pop that off with my scraper probably. But the overall finish, I think, looks really nice. And this is a plug. I usually just use a small screwdriver to try to pull that out. And they usually all come. It's one thing about Simplicity support, it cleans up pretty nice. As you can see, there's a little piece into the opening. I'll have to get that when I get to this piece, but right here, with just 3 of the parts popped off, as simple as you saw, that's a beautiful finish, a beautiful part. I think that's nice. My challenge has always been the inner surface of these ears. The upside one doesn't print well. That's this one. So we'll be curious to see how well that comes out. I'll go ahead and start removing these pieces here as I can. You want to coax them, but not be too mean if you can help it. Might need a bigger screwdriver, might not. Oh, there we go. There's that infill, and as you can see, it's honeycombed, like perforated. So you don't really waste a lot of material on infill, which is a good thing. As I look at these, there is some cleanup. This one is most well formed, and this one is on the bottom, clearly. The thing I worry about, I like to test right away, and I'll get some parts off of a machine here to test. I use machines to test other machines. It's just the way it is. Oh, this is what I did. Okay, fine. I'm going to change this one anyway. It currently has a knuckle coupler. Okay, so this is the clean side, so this went down, so this down one here is the best. We think it should be the best. Let's see how it fits in here. It looks like there's a little bit of stuff around the edges. It may not be quite full. No, it's not quite. This is a shoulder screw, and I've engineered this so, or at least I've tried to, so that the shoulder actually pokes through the plastic. Oh, there it does. Maybe it just had a little piece of stuff on it, so that when the shoulder screw is tightened up to the side frame, it's snug, but held nicely in place. Let's try it. Sometimes I can do it this way on this one. First one. Okay, that's held tight, but look at the pivot. The pivot is free. Quite a bit of wiggle though. A lot more wiggle than I would like. Now when I put the other piece on and I put the axles in between, that'll start to maintain the spacing so that the wiggle won't be so bad and the up-down will be much smoother. And you can see here where I've put this rear bump stop kind of on the back, then I have it on the front, so it will only move about 10 degrees, so it's not going to have wild, crazy opportunity to move about. That may be okay. I may want to tighten that up a little bit. I don't know. I'll do some measurements and see what I get out of it, but it does look like it's a little loose. Let's try the other side and see how well it works, because this is an area that I've been working on mostly lately to improve the repeatability and reliability of the fit. Now, as I look in here, I can see there's some stringing. There's a string in the way of that, and a string there. I don't know that that's going to be a big problem. It might actually help if this is a loose fit part. We'll see what it does. Yeah, it goes through, it comes out. Let's see. These are not right left, so they're the universal that go either side. So there is no difference. I just like to get it started and then I can spin it, but my eye-hand coordination is failing lately. That's the secret. Alright, snug that up. It's snug. Okay, look, no wiggle, right? But it pivots, and the screw head pivots with the arm. So the screw head and the frame are one piece through the hole. So this is exactly what I'd hoped to have right there. This one is a loose, and that's because it's actually printed too well. This has a little junk left in it, and it fills the gap. Now if I put this piece on here and just kind of hold it, you'll see that it acts as the bump stop there. You see that? If I can get it up for you. That's how it will stop. And then in the front side it'll do the same thing. I hold that, and I hold this up so you can see it. There's a bump stop there. Same idea. So this looks like it's going to be okay. It looks like it's going to be okay. I can go back in and pull this out probably 1/10 of a millimeter. Try that first. But I'm surprised this was always the sticky one, and it's fine. I'm looking for any other issues, and I don't see that many, so let's try another thing. Let's get this off. Since my test truck already has a pickup part, this one is going to get a coupler, knuckle coupler. Ah! Or is it? Ah! Funny. That is pretty nice. That came out beauteous. Okay, now I'm going to need a insert. I may take a moment and show you how this works. These are threaded inserts. They're brass and threaded inserts. Just checking the printer. I'm going to print another one, and it should sort of fit in here. You see, this hole has a little bit of stuff in it somehow. Clean that out a little bit. I don't know what I might have. Let's see. What do I have? This is probably too big. No, this could work. I usually have them around the sizes that I need, and clean out a hole if I need it. Okay. Then I try to start the screw. Start this. Oh yeah, it fits nicely. All right, so I'm going to go ahead and take this out. So the insert is started, and I have a very scientific mechanism for this. This actually, with this cap on the top, it fits right flush with everything. So that will take a tap and a punch. Now this table I'm on is a little flexible, but it doesn't take that big of a hit, and it's now flush. Then my knuckle coupler, and the factory couplers have the hole in them, screws into the insert. It's snug enough, square, fits, boom, done. Okay, let's go ahead and get the other frame off and see what movement we have with that. Oh, that's funny. I got it loose. My screwdriver is too short. That's the old, there's the new. This we know is a little on the long side, but I'm not gonna fuss with it this time, or do I want to? I don't know. I don't think I have anything tiny to use as a spacer. This kind of a lock washer, but I don't know if that may be too fat. That may be like way too fat. Let's just stick it in there and see what happens. Oh yeah, that's going to bind it up. I need something thinner than that. I have a little piece of wire. I could try that. I don't know how good I am with that, but it's a possibility. There's a piece of scrap wire. Yeah, scrap wire. Let's just see. That helps. Maybe if I tighten it up, that'll be just enough. The thickness of that wire may be all I need. I don't know. We'll give it a shot because I just want to test this with you guys. Nah, it's a little too tight, I think. A little too thick. All right, let's take it off and try another thing, maybe. Let's see what else I can put in there to give it a little space. Well, I have something here I could try. In the old days, right, you'd have to improvise. I have this sheet of paper, which you may not think as much, but paper can sometimes do what you need. Let's see what we got. If it's a little loose, I'm not going to fuss about it. I'm going to go with it because that's not too bad. Let's see if I have some scissors around here, and I don't see any. Isn't that odd? Alright, well, I'll leave it for now. I'm not going to worry about it. Let's put these in and see how well they fit. I usually put one high and one low, like that, and then I put that in, and then I put in the low one, I bring it in. There we are. Boom, boom, fits. Nice action, I have to say. Nice action. Okay. Now I got to put the other axle in. Problem is, this axle is going to be a little flimsy, but we can try it for now. I don't have the other axle assembled yet. There we are, 2 axles. Cut the corner later. So there's the motion. It's going to be a little less than that because this doesn't have the spacer, but that's it. That's the motion you're going to get on the back of the tender. Pretty cool. Now I've opened this hole up. Pull this up out of the way. Push this around here. Push this around here. I'll cut that out in a minute. I opened this hole up, and I was going to use this chassis screw, black all-thread chassis screw, comes off the American Flyer. Oh boy, that works perfect. Now it may not fit this one. I may have to get a different one. I don't know. Let's see. Let's pull it on and see. Will this fit? Nope. I have to get. I thought I printed another one. I don't know where I put it. Let's see. Do I have a different type of screw that'll work? Maybe. Let's see if I can get this guy in. I'm going to have to drill it. I'm not going to do that now because I know I want to get this done. Let's see if this screw will hold. If it'll stay, I'll use it anyway. Yeah, it'll work. Okay, let's go ahead and put this in. So, to assemble this, you take the pivot pin, insert it from the top down, no gaskets, no insulation, no bushings. You start the screw here. Make sure if it's the extension adapter is pointed outward, whichever end it is. You get that started on that screw. You hold the pivot pin with your thumb, and you screw this in. Hold it snug. Oh yeah, oh yeah. There we are. Okay, rolling, articulating. This is not a real spring. I had a real spring here, I think. Let's try and put one in. I'll show you how that works. This is not a spring, it's just wire. This is the spring wire. You have to pre-bend this a little bit to make sure it's in touch with the axle. Okay, looks good to me. Now I thread that down there, hold it. Then I need to thread it through here. My old fingers and my old eyes are just not cooperating very well today. Tell you what, I'm going to get it started on one side, and then I'll finish the other side a different way. I have my techniques. I'll share them with you. I hope you're not seeing the back of my head. I have a scar. I hit my head yesterday. It's not very fun. Okay, so what I'm going to do is I'm going to pull this wheel out like that, lift it up, bring it back over so the wire is in position. There. And bring the wheel down. You dog. There we go. Then you bring this down. Now it's in position, except it's out of that groove. You want it to be in that groove between the adapter and the wheel, so it's in that, touching the axle right there. Here we go. Boom, boom. Okay, that one is looking good. This one is a little on the weak side. It needs a little more extension, it looks like. See if I can fix that. I can fix that. Pull it out. Oh, it's up there. Oh, I see. It's not up there at that point. There, it's up there. This ought to get it. So, I bring it back. Put this axle in. Make sure it's tucked under. Pull this out, snap it in. Bada boom, bada bing. There we are. There we are. Now I've not soldered the wire in, and we'll probably bend this tab down maybe. I'm not sure. I use them sometimes, sometimes not. It's a preference, but there is a hole here and there's a hole here, so you can bring the wires up through that hole. You could use this hole in this case. This is where the reverse mechanism screw would go, unless you're going to put the reverse back in. Then you're going to have to bring them down, probably that hole, up under the reverse and bring them up. All depends on how you're going to assemble your train, what you're going to use for technology. And there is a all-wheel pickup with one pickup to show how it works, but all the parts and the whys and wherefores and the springs and how they work. And when you put two springs on, they pretty much maintain a level position. This will be my fourth assembly that I've completed with these type parts. This is the first time I've used this particular part, which has the extension for the rotation limiter, as I said earlier. I'm also refining my gap here, so I have real good articulation, but I also have not a lot of side room, and when you put two axles in, it really maintains itself quite well. I don't know if you noticed, but the axle, this is the side house, side frame I call it. It was engineered off of some pictures of engines and things that I saw. It's not deadly accurate, but it's similar. In here would go that threaded insert that we use to attach. Threaded insert that we use to attach with our screw there. And these are what they call eyelets. They're just brass things. They use them in clothing and jewelry and stuff like that. Usually you punch them through, and then there's either another side, or you flare that one out and you mash it together. But in this case, we're simply using it as an axle bearing, just like this. We have one on each side, and the axle spins, and it's brass. So a dot of oil, I mean a dot. And there's no electrical connectivity required. Well, this is plastic, right? 3D printed plastic. So it's isolated, and in between here is a piece of plastic. These axles are isolated. So each one of these axles is a pickup point. 2 pickup points. Inner rail, outer rail. The bushing gives you low resistance to rotation, so these things will spin. They'll spin like crazy. And they'll still have, as you can see, this still has the pickup on it, and it still spins like crazy. And there's no weight. So once you start putting, you know, either your lead and your reverse unit or whatever else you put in here, you might need a little weight, but the weight of the tinder body should be plenty to maintain rotation. And on the track, you know, steel on steel, there's that resistance that will cause the wheels to rotate. The brass is very low. You put a little dot of oil on it, and it's really good. These are insulated, so the chassis is not hot in any way. The pickup thingy is not hot in any way. So your electrical work is, everything is on top. If you wire something, what you wire is where the electricity goes. You're not counting on the chassis as a ground. No more. You're carrying the electric. If this is your common and this is your hot, you bring those two commons up, tie them together, that's your common. And you wire that common to the common. You don't wire it to the chassis. I wouldn't recommend it, especially if you're going digital. They all tell you keep your circuits off the frames. So common and hot, go back to the reverse unit, a voltage rectifier, a voltage regulator, soundboards, smoke controllers, whatever you end up putting inside your tender. You've got track power on every wheel. 1, 2, 3, 4, 1, 2, 3, 4, 8 wheels bringing track power up. So you should have a lot of reliability, easy to maintain. This is the old style truck, but there's the truck, there's a frame, there is a axle separator like that, there's a bushing like that, there's the insert, the threaded inserts I showed you, the little brass pieces, the wheels and the axles. Oh, and the I have an old one here and drag it out, but I may have tossed them because I kept hitting the wrong ones. The pivot pin thing that screws in from the top. This guy, 2 of these, 4 of these assemblies, steel wheels or brass. These are steel here. Screw it together. Oh, the wire. I'm debating. I mean, I can make them. I have a technique. I'll be able to make them and form them. Screw those on, and the screws we're using, right? This is a chassis screw. That's a smoke screw. This is a linkage screw. This is a screw for the connector to the drawbar. So you need 4 of those. This is another linkage screw. And when I say linkage screw, it's a short, small head shoulder screw off of like a K5 articulating linkage. And we have those screws or the part numbers. We'll figure that out, put it together for you. There's the kind of screw we're going to be using there. And all-wheel pickup, American Flyer, tender with a drawbar connector or a coupler, knuckle. You could put couplers on both sides. These are universal. It'll take you to this bar or the coupler. And then it could be a tender with all-wheel pickup, or an action car, passenger car for the lighting, any action car that requires pickup. Tenders, my favorite, cabooses, so they'll be getting full track power to the motor, and the tender, the caboose, I'm thinking I could put a smoke in it, I could put some sounds, lighting, and it would not have any interruptions either. The beauty of all this is you're not wasting power, you're not spending amps going through weak or thin wire, you got lots of paths, so you're getting the big energy coming in. Okay, that's what I've done, that's what I've got. This is the part. I felt good about it when I found that screw could go in. I felt really good. So I've gone ahead, I started printing another one, and I'll probably replace that unit, and I'll go ahead and build the wire pieces up. Oops, I keep forgetting where the frame is. I'll build up some wire pieces and put the pickups in, and I'll do some electrical tests so you can see all-wheel pickup, how that works and how it goes together. And then the idea is I can print these parts, I can put them in a plastic bag and send them to you, and you can assemble it and put it on your train. It should be that easy. Oh, one last thing I was going to mention was on these wire pickups, I'm probably going to make a change to this. I could show you the idea right here. This screws down like this, okay, and it goes out, so this is the wheel, and this is where you want the pickup wire to go. So what I may do is come down here, something like that, and then something like that. I'll make it a little longer, but I'm going to put a little bit of a dip right off of this chassis part. That one's a little too close. It's going to be further out. It'll be more like that. And that's what you'll solder to. If you can see that easy. That's what you would solder to. So I can probably build this part, solder the wire to it, and then put the screw and this in a bag and put it all together. You assemble it. That's the idea. and then you can watch videos. I'll make better ones and you can see how it's done. Okay, that's what I needed to do. I wanted to get this documented so that it was clear what it is, how it works, where it's at, and how well is it working. I do still have 2 types of wire that I'm exploring to see which one will be the best. And I have a supplier who's working with me to help pick the best wire, so you may not have the best, the early guys, but as it improves, I'll make replacements and send them out. We will figure this out soon, and you'll be, I think you'll be pleased. It's a good fix for this. Okay, that'll be the show. I'll talk to you guys later.